Welcome back to another video in the Digital Logic Design series of videos. This one is a continuation of the last few videos on Verilog. If you haven't watched those, it's important to start with those, the first three or more that there are. And so we talked about the various reasons why um, we have the Verilog and hardware descriptive language. We talked about what they can do and the coding process and the compilation and the simulation. That's all we're going to do in the class. Of course, synthesis is and routing and timing is when you create the chip. We're not going to go through the physical creation of the chip and using FPGAs and other things, but we're going to get to the designing and writing the descriptive language in Verilog, and then doing the simulation and verification of it. And pretty much always of the three levels that you can work, we're always focused on doing it on the behavioral side. This video is completely focused on syntax, a quick introduction on syntax. The assumption is if you are familiar with either Java or C or C++, because this Verilog description is very much based on C, same as C++ and Java are based on C. So if you're familiar with any of those languages, you should be in good shape. I'm going to use C because that's a root language for all of these things. So as a reference. So first thing we need to talk about is identifiers. The identifiers are things like labels, variables, module names, things like that. And if you want to create those, you can use any letter, digits, $, underscore, up to a 10,024. Now, good practice tells us don't go 10,024. Just do enough, the minimum that sends a message to the user what you are trying to describe, okay? Some valid names would be these. Typically, we don't like to use underscore in our application code or the hardware description language, because typically those are used in the system level. So we just to avoid conflict, let's not use underscore in the front. Just use a character in the front and you will be safe. The other thing to be worried about, think about, not worried or concerned, but think about, is you cannot use the reserved words. These are the words that mean a special thing to the computer. You can't use it always, and for, if, not, those kind in module, this that kind of stuff, because they're meaning something specific to the these are called reserve words, and you cannot use them for the identifiers variables. Okay. The other thing, the comment is identical to C and Java and all that, // anything after // // is comment. Computers doesn't execute it, it's not needed. For multi-lines, you can use that. I just most people have gone kind of away from this, and // if you want many lines, just put // in front of all of them and write your thing. But this is available. This is another function that's available. You start your comment with a /* and finish your *// and everything in between those two special character sets is comments, and nobody cares. The other thing to be careful of is this language is case sensitive, and which means that if a variable name or whatever is case sensitive, so capitals count, C in a count will be different than a small letter C count. So just be aware of that, that if you mistype, you're creating, and well, you're going to get an error, thank goodness, because this is a tightly typed, strictly typed language, which means you have to declare a variable before you use it, but it could cause its own trouble. Just be careful. And then numbering numbers are really important, because you can use numbers in any format as you're working on. So they have a very specific way of showing a number. A number, if you have a sign, plus or minus, if you leave the sign off, it's going to assume it's plus. If you leave, this size is talking about the number of characters used to represent your number, not the maximum or minimum of your number. It has to do with the number of bits or number of characters. Actually, better way would be number of characters. And it's going to be in decimal, which meaning if you say 5, it's going to assume that whatever base you're using, you're going to have 5 characters representing it. if there are not enough character, what it's going to do is going to add trailing zeros to it. For example, if you go here, for example, this is says I have 5 plus, the sign is not there, so I assume it's plus. Apostrophe B says, okay, that means my base is binary, and 1, 1. 1, 1 is only 2 characters. So how do I fill it in? I put 0, 0, 0, 1, 1 in it. That's all. Here's a hex value, and they, in this particular case, not only it didn't define what it is, what plus or minus, it didn't say how many characters. In that case, it's not specified, so it's just gonna do hex number 2FA. Oh, by the way, and if you put nothing, if you don't put the sign, size, or base in there, it's gonna assume you're a decimal. So that's how you make constant assumption, values assigned to a variable. String is going to be double quotes on both, and be a little bit careful because when you copy and paste from different documents from different systems, sometimes these double quotes change in characters. So just be aware of those. And logical values, yes, we know about 0, we know about 1, but there is Z is another value you can assign. That basically says this thing is floating, it's not connected to anything. That's what it means. And X says, I don't know, but there is a value here, but I don't know what the value is at this point. So you can actually have 4 assignments in the if you declare a variable a logic like a register, and you want to assign values to it, you can have 4 values you assign to it, and each one has a specific meaning. You already seen this in earlier videos. If you want to define a module, you have to say the keyword module, the name of the module, all the inputs and all the outputs, comma separated. And then for each one of them, say, are they in or out, input or output, and why or not. And you can actually put, instead of doing this in 2 lines, you can say input, wire, import 1. And if you have many imports, you just put them, comma, separate them forever and ever, and you're fine. You can have all of this defined on the same line and output on a separate line. Typically, in our case, we do register because a lot of times we want to keep that value to the outside around, even when the input has changed, as long as we haven't assigned it specifically to a variable, to that variable. Typically, if you're doing a sign and you're assigning a value to another value, you have to use a wire because that's more of a combinational logic assignment. And then, of course, your code, the actual code that does the work goes in here. Right now, I don't have anything, just set statements and then end of module, just giving you kind of the format. Again, in the previous videos, there are a number of examples provided. As the video goes through, you can kind of see how these are used in those videos. Assignments. Okay, this gets kind of interesting. When you go to do the work, this piece of the code, you create modules that actually does the work for you in here. There are 3 kinds of, I'm sorry, not module, but blocks. There are 3 kinds of blocks we have that we use. One is called the initial block. One is, that is used pretty much for things that you want to happen once in the beginning of the code and never again. So this is how we do it. We say initial, begin, end, and whatever you want to happen right here. These are assignments of different values. And if you notice, we'll talk about this later, but there are various kind of variables you can use as well inside. These are not implemented, but used to describe the behavior of the code. But anyway, initial is one type of block. Assign is another block, and this is purely used for combinational logic and is continuously executed. So when you say assign present equal next, that means I'm going to take a wire from next and connect it to the present. So anytime next change, present changes immediately. So these are called combinational. In this assignment is a very special assignment called a blocking assignment, which means if this line comes first, this line gets executed before the next line. And we'll talk about that more as well. The next thing is kind of putting it together. We have the initial clause. Now we have some assigns. And assigns, you can put a pound something. So if you want this assignment to happen first and then wait a certain amount of time to do something else, this is, so if you ask what is 5, the 5 is the time scale, the unit of time scale. Default is 1 nanosecond, but you can put a statement here and change it if you like. But typically we don't do that. It's just this happens, then 5 nanoseconds later, that happens. So nanosecond is the units in the mud. The last but not least is the always block. Always blocks are very, very useful because what they do, they allow us to wait on a change on another signal or the same signal before we execute a code. So here's an example. So this one actually has none, which means it's got to do it all the time. So that's not very interesting. This is almost like a sign, but this is more interesting. This one basically says, hey, only do this assignment between begin and end of always when either bin changes or clock changes. So if either one of those two change, then you can go ahead and make the change. And then, oh, and also you can be more specific. Say, I only want you to execute this thing if it's a positive edge of clock, or vice versa, a negative edge of the clock. NEG would be the negative edge. Okay, so these are the 3 blocks. So we've got an initial block, we've got a assign, and we've got always block. So they each do a different things. Now, one thing we need to remember, if you notice, now we have a new kind of assignment, is a less than sign and equal. And it's really important to talk about what that is. And I want to do that with the little table I have down here. So what happens, these are called, the funny looking things, that new assignment is called the non-blocking and blocking. So what's the difference? The blocking basically says, I'm going to block the rest of the code until this is executed. Then I'm going to do this. Then I'm going to do this. So it's very sequential assignments. So first thing happens, second thing happens, third thing happens. So when a positive edge of clock comes along, A is going to be assigned to Q, Q1 is going to be assigned to Q2, Q2 is going to be assigned to output, which means at the end of this, all of this, A out is equal to Q1, equal to Q2, equal to A. On the other hand, when you have this kind of assignment, and this side has to be a reg for this thing to work, okay? You can't work, this is not going to work if it's not a reg on this side. But this is called a non-blocking, which means once this clock changes, then it's going to come down and it's going to make an A assignment to this, Q1 to this, and Q2 to this before anything else happened, okay? So basically what this means is that the out will take on whatever the value of Q is, not A in this case. So if you look at it, A comes in here, and the first clock only makes the assignment to Q1. Q2 doesn't change, and out doesn't change. So that's really important to kind of keep this image in your mind when you're looking at it, and keep this image in your mind when you're looking at the blocking one. The blocking one basically says A comes in, the first clock, I'm going to come in here, make the assignment to Q, but since Q2 happens next and out happens next, everybody's going to be A. In this case, only Q1. In this case, only Q1 will take on the A value, and the rest of them will not change their value. Okay. All right. So that brings us to the end of this video. As a summary, oh, well, let's do one more thing. Let's do the operators too. It won't take too long. You've seen in C they have operators. So we have the logical operators, which basically says true, false, and gives you a true or false answer. This is a negation. If it's true, negated becomes false, false becomes true. And if true and true, get a true, otherwise you get a false. And by the way, it doesn't have to be binary. It could be anything on either side. You just got to say, if this is non-zero and this is non-zero and I'm ending it, I'm going to give you a 1. If both of them are 0 or one of them are 0, I'm going to give you a 0. Or, of course, that's the or work. Bitwise, on the other hand, takes each individual bit and ends them together. For example, if this was a logical OR, the answer would be a true and you're done. 1 bit true and you're done. In this case, it returns a 4-bit, and what it's doing is taking this bit, ORing it with this, taking this, each individual bits are ORing with the corresponding one to give you the answer to it. So that's a bitwise. Relational makes sense when I want a conditional to test The condition, is it equal, is it not equal, is it greater, less than, greater than or equal that, they use relational ones, and of course arithmetic, multiply, divide. And maybe the only one that might be somewhat new to some of you is the modulus, which is the remainder. So A modulus B says, if I divide A by B, what is the remainder? Okay, that's pretty much it as far as this video is concerned. So we will continue with a different video on the rest of it. So in this video, what we've started by talking about some syntactics, some semicolons, and when to use those at the end of every statement, how do you write a comment and things like that. And as we go further down, we talked about the various blocks, how you represent a number and various blocks that are available, such as always, assign, and the initial block. And then we came down and talked about different kind of assignment, blocking assignment, non-blocking assignment, and that brings us to the end of this video. Thank you for watching, and see you on the next video.